Hello friends, in this video we are going to solve linear programming problem by using graphical method. Before we actually start with example, we will see why we use graphical method. Linear programming problem model applied in various industries. To solve linear programming model, we have various techniques such as simplex method, Hungarian approach, graphical method and etc. But especially graphical method is used when we have only two decision variables. For example, in this equation, this is equation given and we have to solve this linear equation. So here we can see that there are only two variables, x1 and x2. So these are only two, so we can easily apply the graphical method. And what we use in graphical method, or why we use these graphical methods. Graphical method is specially used to get the optimal solution. Optimal solution means what? Optimal means either we have to maximize or minimize something. So we can maximize the profit in the industry for particular product, or we can minimize the cost of the product in the industry for particular product. In that, we have some decision variables. For this example, in this equation, we can say that x1 and x2 are the decision variables, and we have different constraints. Constraints are simply the equations given in the example. So this is one equation, this is the second equation, and the optimal solution, whatever we want to find, is we have to find the maximization of these two constraints. We have to find maximum profit or maximum something for this x1 and x2. Now we will solve the linear programming problem by using graphical method. Now example here given is in the form of English statement. So for solving any linear programming problem by using graphical methods, we have 5 steps. These steps are: first, formulation of linear programming problem, writing equation. Second method is to find coordinates, or we can say that the coordinates, or we can say points on the graph. Third, we have to draw the graph. Fourth method is we have to find the feasible solution. And the last method is to find the optimal solution for the given problem. These are the 5 steps. As this is the theoretical statement given in the problem, so we will start with the first step, that is to write the equation or formulation of LPP. So instead of reading each and everything, we will search for the keyword product in the given equation. Here given example. So here given is that a furniture manufacturing company plans to make 2 products. So here we found the word 2 products. So means product, wherever we found the product, we can easily say that this is our decision variables. So products given in this example are chairs and tables. So these are our decision variables. So we will say, assume that chairs is x1 and tables is x2. Next thing we have to find for the available resources. Now in the next line, from its available resources, now this will tell you products, then resources. How many resources we have? Which consists of 400 board feet of wood and 450 man hours. Means totally we have only 2 available resources, that is wood and man hours. So we'll write that resources, board feet of wood, and second is man hours. How many resources you have, that many equation or constraint you will have in your problem. So that many constraints or equations you will have in the example. So here we have only two resources, means we will have only two equations for solving in our problem. Now next, we will try to write this in the format of equations. We will read the next statement, that is, company knows that to make a chair, means for x1, what we will make a table. So that will be very easy for us. Here the products and here the resources. Chair, first product is chair, second product is table, and availability of resource, we can say this is x1, x2. First resource is board feet of wood, second is man hours. So we'll write this. So given is company knows that to make a chair it requires 5 board feet. We'll write this in this table. For chair, means only for the x1 it requires 5 board feet and 10 man hours, and has a profit of rupees 45. So now here the term profit is also coming. So this is the keyword apart from product and resources. So we will write separately the word profit. The profit for this chair is 45 rupees. While each table, now here comes our next product, that is table. So we will write this, we'll look for the x2 in our table. Each table uses 20 board feet, so we'll write 20 here in the row of board feet of wood next to, and 15 man hours, and has a profit of rupees 80. So profit is rupees 80. Okay, now we have written this, and in the first line there was something given, was first two lines, which consist of available resources, which consist of 400 board feet of wood. So to complete this table, at the end of wood line we will write the availability, that is 400 and 450 man hours. So this row 450 is availability of total man hours. So we have completed our table. Now for finding what exactly we have to find in our LPP by using graph method, we have to directly go for the last two lines in our problem. So we will search for the last two lines, that is this lines. Objective is to maximize the profit, means here our optimal solution, whatever we want to find, is to maximize the profit maximization, and how many chairs and tables the company can make keeping within its resource constraint. Okay, so now we have already drawn this table, we have already written this table, so we will write this in format of equation. So this is the final thing we have to find. So this is always written as Z, and what we have to find, that is Z is our profit, and Z we have to maximize or minimize, we have to maximize. So we will write Z max is equal to, what is the profit we are getting from the two product, that is from chair we are getting 45 profit for x1, plus for x2 what we are getting profit of 80 rupees, this is for x2. So we have written this in the format of equation. Now our problem is to maximize, so we will have, as we already consider, as per our resources we will get that many equations. Apart from this equation we will be having only two equations. So these equations are for first resource, that is for wood, we will have equation that is 5 times of x1 plus 20 times of x2, and our optimal solution, whatever we want to find, that is maximization. So here we will write less than or equal to 400, that is availability of wood, board feet of wood. Now the next equation we will get, that is for man hours. So we will write the equation that is 10x1 plus 15x2, and maximization problem, so less than or equal to 450, that is availability of the resources. These are my two equations, 1, 2, and here obviously x1 and x2 will be greater than equal to 0. Now this is our formulation of equation. Now we have to find the coordinates or points. Now the next step is to find, we have formulated our equation. Now the next step we have to find the coordinates or points on the graph. For finding coordinates or points on the graph, we have to consider the equation we have in our formulation of LPP. Now we have only these two equations. So first time assume first product as 0, next time assume second product as 0, and whatever points you are getting, that will be the points for your equation. So we will see this equation 1. We will write the equation 1. So equation 1 is 5x1 plus 20x2. Now we will approximately consider this as equal to 400, as we have to find the points on the graph. Now what we will do, we will put x1 as 0. Now we will keep that thing in the equation. 5 into 0 plus 20 into x1 is equal to 400. So this will be 20 x2 sorry, is equal to 400. So this will be x2 is equal to 400 divided by 20. So it will be 2 2s are 4, 2 2s are 4 and 0. So x2 will be 20. So your first point is in the format, always our points are in the format of x1 comma x2. So this point will be 0 comma 20. Now in the same way, the same equation, that is equation 1, we have not completed yet with the equation 1, that is 5x1 plus 20x2 is equal to 400. Okay, now we are writing the equation 1, as we are not completed with this equation. We will try to find the other coordinate. Now first we have put the x1 as 0. Now we will put x2 as 0 and we will find what is the x1. So we will write 5x1 plus 20 into 0 is equal to 400. 0 into anything is 0. So it will be 5x1 is equal to 400. So x1 is equal to 400 divided by 5. 5 8s are 40 and 0. So x1 will be 80. So this our point is in the format of x1 x2. So this is 80 comma 0. The next point is 80 comma 0. Now we will try to find the 2 points from the next equation, that is equation 2. Our equation 2 is 10x1 plus 15x2, which is less than equal to 450, but we have to find the points, so we will make it as 10x1 plus 15x2 is equal to 450. Now for finding 2 points, first we will keep 1 point as 0, so we will put x1 is equal to 0. So it will be 10 into 0 plus 15x2 is equal to 450. So it will be 0 plus 15 x2 is equal to 450. So x2 is equal to 450 divided by 15. 15 3s are 45. So it will be x2 will be 30. So our point is 0, comma 30. This is x1 and x2 value. This is our third point. And as we have kept x1 as 0, so we'll keep x2 as 0 for the next time. x2 is equal to 0. So our equation will become 10x1 plus 15 into 0 is equal to 450. So it will be 10x1 is equal to 450. So x1 will be 450 divided by 10. So it will be 45. So our last point is x1 comma x2. It is 45 comma 0. So 4 coordinates that are we have get from 2 equation, we will get equation, that means equation into 2 points, that is we are getting the 4 points as 0 comma 20, 80 comma 0, 0 comma 30 and 45 comma 0. We'll label this point. These 2 points are from equation 1 and these 2 points from equation 2. So we'll label this as A, we'll label this as B, this as C and this as D. So we are getting this 4 points A, B, C, D. So next step, we have completed with the second step to find the coordinates. The next step is we have to draw the graph. Now for drawing the graph, we have to draw the line for x1 and x2. So now from the equation, we are saying that x1 is greater than equal to 0 and x2 is greater than equal to 0. Means we will have 4 quadrants. This is line for x1, this is line for x2. As x1 is greater than or equal to 0, this is positive part for x1 and this is negative part for x1. As this is greater than equal to 0, means our x1 will lies here and our x2 is greater than or equal to 0. This is positive part for x2 and this is negative part for x2. As our x2 is greater than or equal to 0, so this here x2 will lies. So we can conclude that our x1 and x2 will lies in the first quadrant, first, second, third, fourth. So it will lies in the first quadrant. So we have to draw our equation. We have to plot these points and draw the line in the first quadrant only. As I was not having graph paper, so I have drawn this on the this pages. So I assumed each 1 centimeter on the graph as 10 points. As our points are in the format of 0, 20, 80, 0, 0, 30, 45, 0. So I make each point, each duration of the 1 centimeter as a 10 unit. So we have to plot these points on the graph. We have to put the points on this graph. First point is 0, 20, 0 of x and 20 of x2. So here is our first point. This is our A point, that is 0, 20. The next point is 80, 0. So the next point is x1 ka 80. Here 80 of x1 and 0 of x2. So this is our second point, 80, 0. This is B, this is A, B. This is equation 1. As we have completed one equation, we will draw this as a line. We have drawn this line. Now the next equation, that is having 2 points. First point is 0, 30, x1 0 and 30 is of x2. So this is the second point. Third point, that is C. This is our C, 0, 30. And the last point is 45, 0. 45 on x1. So here is our 45. And x2 is 0. So this point lies on this line. That is the last point, D, 0, 45. So these are our 4 points. So I will draw this point line for these points. This is equation 1. This is equation 2. Now the next step is we have to find the feasible solution on the graph. The given problem is to find the maximum profit. Easiest thing we can say that whenever we want to find the maximization of the given problem, our feasible solution will lies nearest to our nearest to our origin. So nearest area to our origin is this area, and if this is for maximization problem, and if our problem is to find the minimization of something, so that will be the meeting point of two equations or two or more equations and the point away from the center. So this will be our area for minimization. As this is maximization problem, so whatever points which are nearer to the origin, so from this origin, this is nearest point, this is meeting point of two equation. So we'll give label to this point as suppose A, B, C, D and E. This is also second point. This is the nearest point. Now we'll make the region of this, and this we say that this is our feasible solution. So this is our this is for maximization and this region will be for minimization, but we are solving only the maximization problem, so we will not consider this part. We will consider only this part as our feasible solution. We will find the coordinates for this point. So as I am not drawn this graph on the graph paper, so my points will be slightly different or maybe exact. So we'll see this is (25, 14). Now we have to find only, we have find the points for E or coordinates for this meeting point, that is 25, 14. You may get that as 25, 15 or something, because I have not drawn this on the graph paper, so I may not get the exact points. So but we'll continue with this point. Now we have to find the last step in this graph, in this problem is to find the optimal solution. We have to find the maximization of the profit. So this is our feasible region. We will just consider the points which are extreme to the our feasible solutions. So this is a region of our feasible solution. So we'll consider only the corner points of our feasible solution. So there are 1, 2, 3, 4 corner points of our feasible solution. So we'll give this name as O, that is 0, 0. We'll write this point. These points are A, D, E and O. This is 0, 0. Now this is the point 25, 14. Now D point 0, 45 and point A 0, 20. Okay, just wait. D is 45 comma 0. He made a mistake here. 45 comma 0 comma 0. Now we will consider only these 4 points for our finding of the optimal solution. So we'll carry only these 4 points. We have written these 4 points and we will see what was the equation we have. We have written this equation at the starting first step. So this was our profit equation. So this is, suppose this is equation 1, Roman 1. Along with these 4 points, we will write that Roman 1 equation, and we just have to fit these points. We just have to write x1 and x2 values of these 4 points in these equations, and we will get the solution. So we'll assume for point A the same equation, and we will put the value of points in that. 45 x1 value is 0 plus 20 80 into x2 value is, this is x1 value, this is x2 value. We will simply put this points value of x1 and x2 in this equation. 80 into 20. Now we will write the next equation, that is 45 into x1 is here 45 plus 80 into here x1 is 0. For this equation, 45 into x1 value is 25 plus 80 into x1 value is, x2 value for this is 14. Now for this point, 45 into x1 value is 0 plus 80 into x2 value is 0. Now this is equal to, we'll find the values. 80 into 8 into 2, 16. So it will be 1600. Now for this 45 into 45, this is coming out to be 2025. This will become 0. For this equation, we are getting the value as, we're getting the value of this is coming out to be 2145, and this is coming out to be 0. Now our problem is to maximize the profit. So we'll look for the maximum value for maximum value among all these 4 points. So maximum value among all this is, for this, that is 2145. So we'll write that point is E, which is 2540, which is equal to having value of 2145. So now we'll conclude that our profit is maximum with rupees 2145 at x1 is equal to 25 and x2 is equal to 40. So this is our final solution. Thank you.